A woman on a rocket traveling at 0.51 c with respect to Earth observes a meteor come from behind her and pass her at 0.49 c. How fast is the meteor moving with respect to Earth? So you can see I've got my diagram here. Earth, here's the meteor and its velocity, and here's the rocket with its velocity. It's worth noting the problem doesn't tell us if the rocket is going away from Earth, as I've drawn it, or toward Earth. Turns out it doesn't change the answer here for this problem, so it's not of consequence. Obviously, if I had drawn the rocket going toward Earth, I would have to change the direction the meteor was going as well. Okay, let's take a look at the formula here. So this is the formula, the relativistic addition of velocities. And all these velocities are x components. So we've got the velocity of A with respect to C. That equals the velocity of A with respect to B plus the velocity of B with respect to B all over 1 plus the velocity of A with respect to B times the velocity of B with respect to C all over C squared. So what are these capital A's, B's, and C's? What do they represent? They represent the three different reference frames. Usually we're talking about an object that's moving, like in this case the meteor. So the meteor would be A, and then B and C would be the reference frames that the various velocities are measured with respect to. So when using this formula, it's already solved for this value, for the velocity of A with respect to C. So and this is my advice, of course, but the best way to do this is to go ahead and say, all right, like in this problem, I'm solving for the meteor. So whatever you're solving for, the velocity of whatever you're solving for, you want to call that A. Okay, so in this case, it's the meteor. I want the velocity of the meteor, so A is going to represent the meteor. Okay, so let's do that in a different color here. So here's A. So my meteor is A. And it says I want the meteor with respect to Earth. So that makes C, since this is the velocity of A with respect to C, that's going to make C Earth. So Earth is C, the meteor is A, and obviously that makes the rocket B. Okay, so these velocities that we're told, like the woman on the rocket traveling at 0.51 c with respect to Earth, that means this is the velocity of the rocket, B, with respect to C, and it's 0.51 c. And then the meteor is coming from behind and passing, so the meteor is going 0.49 c. And let's see, let's read this carefully. The woman observes a meteor come from behind her and pass her at 0.49 c. So this is the velocity of A with respect to B, because that's the velocity that the woman sees, and the woman's on the rocket. So this is 0.49 c. Okay, so I can take these values now and I can put them into the formula. So the velocity of A with respect to B and the x component. Now, I need to take a moment to talk about this. These are all x components, so they can be positive or negative. I'm going to call right positive, but you need to pay attention. That's why you need to do your diagram. You need to have a diagram. You need to have arrows showing which way things are going. You need to label your velocities carefully, and you need to identify, okay, are any of these, which of these are positive and which are negative? In my case, mine are both going to the right. I'm calling right positive, so these are both going to be positive. Okay. So I have velocity of A with respect to B, that's 0.49 c plus 0.51 c all over 1 plus 0.49 c times 0.51 c all over c squared. And of course, these c's and the c squared are going to cancel. And so when I do this all out, I get 0.8 c. It's not exactly 0.8, but you have to go out like 5 digits before you get a non-zero after 8. So this is the answer, 0.8 c. Now, one other thing I want to mention, this didn't come up in this particular problem, but I want to point out that, and let me do this in a different color just so it stands out. So let's just look for a moment here at this. So I said that the velocity of A with respect to B was 0.49 c, and more specifically I said its x component is 0.49 c. Okay. That means the velocity of B with respect to A and the x component is going to be negative 0.49 c. So what this is saying is the rocket sees the meteor moving in the positive direction at 0.49 c. The meteor is going to see the rocket moving to the left at 0.49 c. In short, what this is saying is that if I know the velocity of object 1 with respect to object 2, it's saying that the velocity of 1 with respect to 2, the x component, is equal to the negative of 2 with respect to 1, the x component. So this is a general relationship that I didn't need here in this problem, but you might need in a subsequent part to this problem.